Hey, hello there. So I'm going to talk about an easy level question today. It's a 896 monotonic array. We have an array of integers and we want to determine whether it is monotonic or not. And for an array of integers to be monotonic, it could be either monotone increasing or monotone decreasing. That means as long as it belongs to one of those, it can classify it into one of those, it's actually fine. It could actually be both of those, we will see later. For monotone increasing and monotone decreasing, they all includes the equal case here. So in the most extreme case, we will have the whole array be the same number all the way. So as this array 1, 1, 1, it can be classified as monotone increasing and monotone decreasing in the same time. So that's actually good. To solve this, when you're reasoning about what's the case when we should return false, it's actually either a peak or a valley. And then I was originally trying to solve it in the peak and valley finding kind of approach, and the code becomes a little bit messy. So I step back and think, what's the better way of looking at that? Then with the frequencies, the kind of point of view is not working really well, we better turn back to Bayesian. So the prior is just that we assume it's both monotonic, monotone increasing and monotone decreasing, and then just examine the new data coming in, which are the adjacent two numbers in the array, and use that to update the belief. In the end, we just analyze the posteriors. So in the posteriors, it could be 4 cases, 1, 1, 1, 0, 0, 1, and 0, 0. With the 1, 1 be the prior, it's both monotone increasing and monotone decreasing. The only case it's not good is that it's neither monotone increasing nor it's monotone decreasing. And for this, we actually can detect whether it's flat or not. So if both of the priors is unchanged, we can return it's flat. So if the question has been modified a little bit, instead of return true and false, we should return whether it's increasing, decreasing, flat, or unsorted. We can, if we have this, it should be easier to solve. To fulfill that requirement. So we're going to have 2 variables to keep track of the beliefs, our assumptions. And just going to examine new data to update that belief. We're just going to examine the pairs of adjacent number. If the latter one is strictly greater than the prior one, then it means it cannot be monotone decreasing. So we mark the second flag to be 0. If the relationship between these two numbers is the opposite case, we turn off the, we change the belief on the that is monotone increasing. And in the end, we just return whether it's the first 3 kind of case. So it's either one of those is 1. So this is the code. It's pretty straightforward, and it's a very nice logic behind it. And it can also be easily adapted to solve the, instead of classifying into true and false, you can classify into 4 different categories. So yeah, so that's the question today.